Science species here with Chapter 1 Matter in Our Surroundings. Class 9 Chemistry part. Before moving to the chapter, let's learn what is matter. Matter is something that occupies space and has its own mass. For example, plastic, plants, trees, air, water, food, table, gold, sand, pen, etc. are some of the examples of matter. So all these things occupy space and have their own masses. Both living things and non-living things are matter. So we can say the entire universe is composed of matter. But not all forms of energy are matter. For example, heat, sound, electricity, etc. They do not come under the term matter, as they do not have mass, but they are useful to do work. And we can consider these are the forms of energy. Energy means the ability to do work. Let's check out what is mass. Mass is the amount of matter obtained in an object. Next, we'll check out what is meant by volume, the space occupied by an object. Next is about the composition of matter. It's composed of extremely tiny particles called atoms and molecules. So these atoms, the particles are so small that cannot be seen with naked eye. So we need a powerful electron microscope to see the atoms, like scanning channeling microscope. Let's consider sodium atom. The basic building block of all matter is atoms. It's the smallest unit of ordinary matter that has the properties of chemical element. Atoms are made up of even smaller subatomic particles, protons, neutrons, and electrons. So we can conclude atoms are the basic building blocks of all matter. It generally exists in 4 states, that is liquid, solid, gaseous, and plasma state. So we can conclude the universe itself is a matter. Let's begin the lesson, matter in our surroundings. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. So everything in this universe is made up of material which scientists have named matter. So the air we breathe, the food we eat, stones, clouds, stars, plants, animals, even a small drop of water or a particle of sand, everything around us is made up of matter. We can also see as we look around that all the things mentioned above occupy space and have mass. So what is matter? Matter occupies space and has definite mass. Does all matter look different? So what distinguishes matter? So in this lesson, we are going to learn in detail about this. Since early times, human beings have been trying to understand their surroundings. So the composition of the matter in ancient time, according to researchers, early Indian philosophers, they classified matter in the form of 5 basic elements. That is a Panch Tattva. They are the air, earth, fire, sky, and water. Now, according to them, everything, living or non-living thing, was made up of these 5 basic elements. Ancient Greek philosophers had arrived at a similar classification of matter. Now, let's learn about matter based on its physical properties and chemical properties. Clear? Physical nature of matter. Matter is made up of particles. So here there is a sand. Activity over here. One school believed matter to be continuous like a block of wood, whereas other thought that matter was made up of particles like sand. So let's perform an activity to decide about the nature of matter. Is it continuous or particulate? So here, what you should do, take a 100 ml beaker, fill half the beaker with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Observe any change in water level. What do you think has happened to the salt? Where does it disappear? Does the level of water change? No, so it occupies a space, right? So here, what happens when sugar or salt dissolves in water? Its tiny particles break off from a from the solid sugar or salt crystals. So the sugar particles or the salt particles, it go into the space between the particles of water and mix with them, right? So we got sweet water and salty water. So what can we conclude here? The matter, here sugar, salt, clear, and water, it's made up of small particles. And particles of matter, here we can say water, right? It has spaces between them. So when we dissolve salt in water, the particles of salt get into the spaces between particles of the matter. Next let's check out how small are these particles of matter. Take 2 to 3 crystals of KMnO4, that is potassium permanganate crystals, and dissolve them in 100 ml of water. So in this experiment, just a few crystals of potassium permanganate can color a large volume of water, about 1000 liters. So what can we conclude here? Just one crystal of potassium permanganate which keep on dividing themselves into smaller and smaller particles. That means a particle of KMnO4 is very small and tiny crystals of KMnO4 contain millions of particles which keep on dividing themselves into smaller and smaller particles. Next we are going to learn evidence for each characteristics of particles are spaces between them. As we have learned, when we add salt to water, it dissolves and disappears. This is because the particles of salt get into the spaces between the particles of water, that's water molecules. It shows that there is enough space between particles of matter. Similarly, when you drop a stone into a pond, what happens? The stone sinks into the water, isn't it? It's because of the space between the water. Next, let's check out particles of matter are continuously moving. Here, it's because of one of the most important property, that's diffusion. So diffusion is the most important evidence of particles of matter being continuously in motion. So what is diffusion? It's a mixing of substance with another substance due to the motion of their particles. And you know, diffusion is the highest in gases and it's the least in solids. And the rate of diffusion increases with increase in temperature. An increase in temperature causes an increase in the kinetic energy of the particles. Therefore, at a higher temperature, particles move more rapidly and diffuse more easily. Let's check out. The fragrance of an incense stick burning in one corner of the room can be smelled in another corner. It's because a burning incense stick produces gases. So the particles of these gases diffuse or mix with the particles of the air and move rapidly in all directions. Next one, about the same way, it's about the example of the drop of ink in the water. Right, it slowly spread its on, right? Yes. Next one, when copper sulfate crystals are added in water, the blue color copper sulfate slowly spreads throughout the water, isn't it? This is due to the movement of the copper sulfate particles within the moving particles of water. In other words, we can say the particles of copper sulfate diffuse into water. So on heating, as the kinetic energy of the particle increases, diffusion becomes faster. Next, we will learn about particles of matter attract each other. It's easy to break a piece of ice or chalk, but it's not an iron nail. This is because in each of these substances, the particles attract each other with a force. This force of attraction is weak in a piece of ice or chalk, but it's strong in iron. Same way, take some water in a container, try cutting the surface of water with your fingers. Were you able to cut the surface of water? So what is the reason? About these activities shows that particles of matter have force acting between them. This force keeps the particles together. Strength of this force of attraction varies from one kind of matter to another. So here are the questions. Which of the following are matter? Chair, air, love, smell, hate, almonds, thought, coal, cold drink, smell of perfume, etc. So as you know, matter always occupies space and has definite mass. And it exists in three physical states: solid, liquid, and gas. So here the chair or almond, they are the solid state of matter, and cold drink, liquid state of matter, air, smell of perfume, that's the perfume particles in air, that's a gaseous state of matter. And the love, hate, cold, smell, and thought, these are sensations, emotions, and as they are not considered as matter. Let's check out the next question. Give reasons for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. As we learned, rate of diffusion increases with increase in temperature due to the increase in the kinetic energy of solid food particles diffused in air. The kinetic energy of hot food particles is high as compared to cold food. Thus, the smell of hot sizzling food reaches us even at a distance. But to get the smell from cold food, you have to go close. So what is kinetic energy? The energy possessed by these particles by virtue of their movement. Next question. A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? As you know, one of the characteristics of matter is particles of matter attract each other, right? So the force of the particles attraction, we can say solid, liquid, gas. Clear? So gas is having the more space and solid has a less and liquid less, right? Thus, liquid particles have less force of attraction between them. So we can cut the force of attraction easily. And there is also space in between the particles of matter. That's why a diver is able to cut through water in a swimming pool. Next question. What are the characteristics of the particles of matter? The characteristics of particles of matter are: particles of matter have space in between them, they are continuously moving, and the particles of matter attract each other. Before moving to the three states of matter, just we can revise what we have learned. How do we get the smell of perfume from even several meters away? Perfume changes from liquid to gas very fast. The particles of perfume easily get mixed with air particles. In other words, they diffuse in the air to reach our nostrils. So we are able to get the smell of perfume from even several meters away. What happens to the particles of matter, next question, when its temperature rises? As the temperature rises, the particles of matter start moving faster. In other words, with increase in temperature, the kinetic energy of the particles increases. Next is about the three characteristics of the particles of matter. They are: the particles of matter have spaces between them, the particles of matter are in a continuous motion, the particles of matter have a force of attraction between them which keeps them together. What's the relationship between the movement of the particles and kinetic energy? Movement of particles and kinetic energy are directly proportional to each other. The greater is the movement, the more the kinetic energy will be, and vice versa. Next, we are going to learn about the three states of matter in detail. First, we will learn about the solid state. So, states of matter and the interconversion, that is, on the basis of physical states, matter can be classified into solids, liquids, and gases. Let's check out what is solids. In solids, the particles are closely packed. The force of attraction between the particles is very strong. Let's check out the properties of solids. Solids have a fixed shape and volume. They cannot be compressed much. They have a high density. They are rigid and do not flow. For example, a rubber band is a solid but does not have a fixed shape. The change in the shape of a rubber band is due to the application of force. So when the force is withdrawn, it regains its shape. Salt and sugar are solids, but they take the shape of the container. Each individual crystal of salt and sugar has a fixed shape and size. The crystals are very small in size and therefore fill every part of the empty space inside the container. Next example, sponge is a solid, but it is compressible. This is due to the presence of tiny holes filled with air. When the sponge is pressed, what happens? The entrapped air is expelled out and the sponge, despite being solid, is compressed. Next, we will learn about the liquid state. In liquids, the particles are not as closely packed as in solids. The force of attraction between the particles is weaker than in solids but stronger than in gases. Let's check out the properties of liquids. Liquids do not have a fixed shape. They take the shape of the container. They have fixed volume. They cannot be compressed much. And they are usually less dense than solid. They flow easily and are also known as fluids. Next, as we have learned, solids and liquids can diffuse into liquids, right? The gases from the atmosphere diffuse and dissolve in water. So these gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. All living creatures, they need to breathe for survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Thus, we can conclude that solids, liquids, and gases can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids. This is due to the fact that in the liquid states, particles move freely and have greater space between each other as compared to particles in the solid state. Let's learn in detail about the gaseous state. In gases, the particles are very loosely packed and are far apart from one another. The force of attraction between the particles is very weak. So let's check out the properties of gases. Gases have neither a fixed shape nor a fixed volume. They take the shape and the volume of the container. They can be compressed easily. Their density is very low. They flow easily and are also known as the fluids. A gas is a fluid form of matter which fills the whole container in which it is kept. Being fluids, gases also require a container to keep them. A gas does not have a free surface, so a gas has to be kept in a closed container. A gas will escape if kept in an open container. This is why gases are usually kept in airtight gas cylinders. For example, cooking gas, LPG, is kept in airtight metal cylinders. So, from this we can conclude that liquid and gases are known as fluids. Characteristics of liquids and gases of flowing easily is called fluidity. So, due to fluidity, liquids and gases change their shapes readily when subject to outside force. Next state is about the plasma state. Plasma state is a fused and ionic state of matter that's present at very high temperatures, like the core of the sun, stars, etc. The fused ionic mass is neutral as it consists of positive ions and a pool of electrons. Approximately 99% of the universe is a fused ionic mass. Let's check out the questions. First question. The mass per unit volume of a substance is called density. Arrange the following in your order of increasing density. As you know that solids are having high density, liquids are having less dense, and gases have density is very low. So let us arrange according to order of increasing density now. Air, exhaust from chimney, cotton, water, honey, chalk, and iron. Next question. Tabulate the differences in the characteristics of states of matter. The differences in the characteristic states of matter are solid, it has definite shape and volume. It is incompressible. The force of attraction between the particle solid is highest. The particles of solid cannot move freely. Liquid state, it has no definite shape but has definite volume. liquid attain the shape of the vessel in which they are kept. It is compressible to a small extent. The force of attraction between liquid particles is less than solid particles but greater than gas particles. Liquid particles move freely. Gaseous state, it neither has a definite shape nor a definite volume. It is highly compressible. The force of attraction between the gaseous particle is least. Gaseous particles are in a continuous and random motion. Next question. Comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy, and density. What is rigidity? The tendency of matter to resist a change in shape. That's called solids are rigid because it's tendency of matter to resist a change in shape. Compressibility, the ability to reduce in volume when force is applied. Fluidity, its ability of matter to flow. Only liquid and gases can flow and they are called fluids. The rest already we have learned. Give a reason. A gas fills completely the vessel in which it is kept. It's because the gas particles move freely in all directions due to less force of attraction between the particles. Gas takes the shape of the container in which it is kept. Therefore, the gas completely fills the vessel. Next question. A gas exerts pressure on the walls of the container. As you know, the gas particles move freely in all directions due to less force of attraction between the particles. So these gaseous particles continuously collide among themselves and they also hit the walls of the container with a greater force. So here the pressure, what is pressure? It's defined as the force exerted by the gas particles per unit area. Thus, gas exerts pressure on the walls of the container. Next question. A wooden table should be called a solid. Yes, a wooden table has a definite shape and volume. It's very rigid and its shape cannot be changed easily. That is, it has the characteristics of a solid. Hence, a wooden table should be considered as a solid. Next question. Air particles. We can easily move our hands. Sorry, next question. We can easily move our hand in air, but do the same to a solid block of wood. We need a karate expert. Here is your answer. Air particles have large space in between them. Due to the least force of attraction between the particles, whereas wood has little space between the particles due to high force of attraction between the particles. And wood is rigid. For this reason, we can easily move our hands in air. But to do the same to a solid block of wood, we need a karate expert. Next question. Liquids generally have lower density as compared to solids. But you must have observed that ice floats on water. Find out why. What is density? Density is mass per unit volume of a substance. As the volume of the substance increases, its density increases. So here, ice is a solid. It has large number of empty spaces in its structure. These empty spaces are larger as compared to the spaces present between the particles of water. That's why the volume of ice is greater than that of water. So we can conclude, higher the volume, lesser will be the density. Hence, the density of ice is less than that of water. Next, we will learn about interconversion states of matter. The three states of matter can be interconverted by changing temperature and the pressure of its surroundings. First, we will see about the effect of temperature. Increase in temperature causes a conversion in the states of matter in the direction like solid changes into liquids, liquids into gases. As you know, increase in temperature increases the kinetic energy of vibrating particles. Moreover, the energy supplied by heat also helps a particle to overcome the force of attraction. The processes that takes place due to the increase in temperature are melting, that means melting of fusion, that is conversion of solid into liquids, evaporation, conversion of liquid into vapors, and sublimation. So what is sublimation? It's a conversion of solids into gases. Next we will learn about what is meant by latent heat. So the word latent means hidden. It's a heat required to convert solid to liquid or liquid to vapor without the change in temperature. As the temperature does not rise, it is considered that heat absorbed by the system remains hidden. Temperature does not rise because the energy supplied by the heat is used to overcome the force of attraction between the particles. So what happens? The particles leave their positions and begin to move freely. Next is what is meant by latent heat of fusion. The amount of heat required to convert 1 kilogram of solid into liquid at the atmospheric pressure and at its melting point is known as the latent heat of fusion. Next is what is meant by latent heat of vaporization. The amount of heat required to change 1 kilogram of liquid into vapors at the atmospheric pressure and at its boiling point is known as latent heat of vaporization. Next we will learn what happens when there is a decrease in temperature. Decrease in temperature causes a conversion of states of matter in this direction. Gases into liquids, liquids into solids. Decrease in temperature decreases the kinetic energy of particles and the particles come closer to each other. Processes that takes place due to decrease in temperature are condensation, freezing. What is condensation? Conversion of gases into liquids. Freezing, conversion of liquids into solids. You have to learn this interconversion of the three states of matter, figure 1.9. Next, let's check out the effect of pressure. When pressure is applied, the particles of matter come close to each other. Gases can be liquefied by the application of pressure and decreasing in temperature. So when pressure is applied, the molecules of gases come close to one another. And when the temperature is reduced, the kinetic energy of the molecules decreases and the gases become liquefied. Let's check out the question. Convert the following temperature to Celsius scale. A. 300 Kelvin. B. 573 Kelvin. As you know, Kelvin is the SI unit of temperature. 0 degrees Celsius is equal to 273.15 Kelvin. For convenience, we take 0 degrees Celsius is equal to 273 Kelvin after rounding off the decimal. To change your temperature on the Kelvin scale to the Celsius scale, what you have to do, you have to subtract 273 from the given temperature, and to convert your temperature on the Celsius scale to the Kelvin scale, you have to add 273 to the given temperature. So here 300 Kelvin is equal to 200 minus 273 degrees Celsius, that is equal to 27 degrees Celsius. So first answer 27 degrees Celsius. Second one 573 Kelvin, that means 573 minus 273 degrees Celsius, that is equal to 300 degrees Celsius. What is the physical state of water? Next question. At 250 degrees Celsius. A. Second one 100 degrees Celsius. Boiling point of water is equal to 100 degrees Celsius. Above this temperature, water exists in gaseous state. Thus, water at 250 degrees Celsius exists in gaseous state. At 100 degrees Celsius, water exists in both liquid and gaseous state. Next question. Why does the temperature remain for any substance? Why does the temperature remain constant during the change of state? Here is your answer. During a change of state, the temperature remains constant. This is because all the heat supplied to increase the temperature is utilized to supply latent heat of vaporization, which does not contribute to increase the temperature of the substance. Next question. Suggest a method to liquefy atmospheric gases. Atmospheric gases can be liquefied by applying pressure and reducing the temperature. Next, we are going to learn in detail about what is evaporation. Evaporation is a phenomenon in which a liquid changes into gaseous state below its boiling point. Water molecules are attracted by other water molecules in all directions. But at the surface of water, the water molecules are pulled only inward, that's below the surface of water. So evaporation is a phenomenon that theoretically takes place in all liquids, but in general, when we say evaporation, we mean evaporation of water. So what is vapor? A substance that can exist in the gaseous state at a temperature at which normally it's a solid or liquid is called vapor. Examples of solid that can exist as vapor are camphor, naphthalene, etc. Next, we are going to learn about the factors affecting evaporation. First one, surface area. The rate of evaporation increases with the increase in the surface area of a liquid. For example, when we spread out washed clothes to increase the surface area exposed to sunlight so that they dry faster. Next one, temperature. The rate of evaporation increases with increase in temperature. This is because the kinetic energy of the particles increases when the temperature increases. Next factor, humidity. It's the amount of water vapor present in the air. The air can hold only a definite amount of water vapor. So if the amount of water vapor in the air is high, the rate of evaporation decreases. Next is the wind speed. Clothes dry faster on a windy day. If the wind speed is high, the particles of water vapor are carried away very easily. Next, evaporation causes cooling. How does evaporation causes cooling? The cooling effect of evaporation is based on the fact that while evaporating, what happens? The liquid draws the latent heat of evaporation from anything it touches, right? So in an open vessel, the liquid keeps on evaporating. What happens? The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cold. How does evaporation cause cooling, right? So when a liquid evaporates, it draws energy from the liquid itself. Hence, it keeps cooling. The liquid draws on the energy lost from the surrounding that in turn become cooler. So one such usage can be seen in the forced cooling by air coolers during summer. Next one, what happens when you pour some acetone nail polish remover on your palm? The particles create energy from your palm or surroundings and evaporate, causing the palm to feel cool. After a hot sunny day, the people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Another example, like can you cite some more examples from daily life? Another example I can say, when we put a spirit at our hand and blow it, our hand feels cold. This is because it's due to the evaporation of spirit, and to evaporate it takes the heat from our hand. Next, why should we wear cotton clothes in summer? To keep ourselves cool and comfortable. Cotton clothes absorb sweat and expose it to the atmosphere. The sweat evaporates, and to evaporate, it takes the heat from our body. As a result, we feel cool and comfortable. Another question is also here. Why do we see water droplets on the outer surface of a glass containing ice cold water? Let's take some ice cold water in a tumbler. So we will see water droplets on the outer surface of the tumbler. The water vapor present in air on coming in contact with a cold glass of water loses energy and gets converted to liquid state, which we see as water droplet. Let's check out the question one by one. Why does a desert cooler cool better on a hot, dry day? Here is your answer. During evaporation, the liquid particles absorb energy from the surroundings, which causes a cooling effect. The rate of evaporation depends on the amount of water vapor present in air or humidity. If the amount of water vapor present in air is less, the rate of evaporation will be more. On a hot, dry day, the amount of water vapor present in air is less. Thus, water present inside the desert cooler evaporates rapidly and it cools the surroundings more easily. Therefore, a desert cooler cools better on a hot, dry day. Next question. How does water kept in an earthen pot, matka, that is become cool during summers? An earthen pot consists of many tiny pores through which the liquid inside the pot evaporates. This makes the water inside the pot cool. In this way, water kept in an earthen pot become cool during summers. Why does our palm feel cold when we put some acetone or petrol or perfume on it? So organic compounds like acetone or petrol or perfume, they are volatile in nature. So when we put some acetone or petrol or perfume on our palm, it evaporates. During evaporation, particles of these organic liquids absorb energy from the surroundings or the surface of the palm, making the surroundings or the surface of the palm cool. Hence, our palm feels cold when we put some acetone or petrol or perfume on it. Next question. Why we are able to sip hot tea or milk faster from a saucer than a cup? Hot tea or milk has a larger surface area in a saucer than in a cup. So the rate of evaporation is faster in case of greater surface area. Thus the liquid cools faster in a saucer than in a cup. For this reason, we are able to sip hot tea or milk faster from a saucer than a cup. Next question. What type of clothes should we wear in summers? In summer, we should wear cotton clothes because cotton clothes can absorb more sweat from our body and expose the liquid to the atmosphere, making evaporation faster. During this evaporation, particles on the surface of the liquid gain energy from our body surface, making the body cool. That's about the chapter Matter in Our Surroundings.